Today I think it's the 28th. Okay, and we have f of x equals 2x minus 4 for x greater than 3, and negative x plus 1 for less than or equal to 3. So if you remember, we have to find the domain. And this is the same with 3 comma infinity. And this is the same with negative infinity 3. So when I look at these two pieces, I realize that the domain is all real numbers. So I will get a chart going, because I need to present the ordered pairs that I'm using. You can use the method in the book. For example, Heather used the method in the book. She likes the method in the book, and I'm fine. It doesn't matter. So negative infinity to infinity. In the chart, I have to have this x value. This is mandatory. And of course, I will have to have 0 as well. I see the notation for the interval, and that's what I'm going to use right under 3. And that will indicate which one will be an open point and which one will be a full point. So between negative infinity and 3, negative infinity and 3 is this line, because it's a line, it's a linear function. And between 3 and infinity is the other one, which is 2x minus 4. Both are lines. I only need 2 points, as we know, to graph a linear function. We only need 2 points. So I will also plug in 1 here, because when I plug in 0, I get 1, and when I plug in 1, I get 0. So these are the x and y intercepts. And then I will plug in 3, and I get negative 2 right here inside. So this will be a full point, 3 comma negative 2. But on the other side, I shouldn't be allowed to plug in 3, but I will. 3 times 2 is 6, 6 minus 4 is 2. Because if I don't plug in 3, then I will have to plug in 2.999999999, and I don't want to do that. So then I plug in 4, the next one, so 4 times 2 is 8, 8 minus 4 is 4. That's all I need to graph this function. So 0 comma 1 is this point, 1 comma 0 is this point, 2, 3 comma negative 2 is this point, and it's a solid point, full point. So then and then 3 comma 2 is this point, but it will be an open point. And then 4 comma 4 will be a full point. And this is it. You know, to identify the range from the lowest y value till the largest y value. So the range is from negative 2 to infinity. Watching me do a problem is, again, not enough for you to be able to reproduce it on your own. That's why I put all those videos up there for you to review and redo and review and redo. You can stop the tape, go back and forth. You can go to the previous semester. I have the videos from the previous semester. Did you see that? Do you want me to show you again where they are? Okay. Good. Anything else? Anything else?
Number 8.
Okay, what does number 8 say?
That's the suppose that Q varies jointly.
Right, so Q varies jointly with V and the square of W. So you have to have a constant, so it has to have K V times W squared. And then now I put in the information. It says if W is 20, and when V is 12, and Q is 80, then I will find K. So then that is 80 equals K multiplied by 12 multiplied by 400. There's no need to multiply this. I still have to divide, but it's easier for me. You can multiply it if you want, but it's easier for me to simplify. See, I say divided by 80, and I have 5. So then K equals 1 over 60. That's the easiest thing to do. If you multiply, then you have to start, okay, now how do I simplify it? So you make your life more difficult. I have to put it back in the equation. So this is Q equals 1 over 60 V times W squared. This is now a law. We found the K, the constant of proportionality. And now we're asked to find Q when W is 10 and V is 15. So W is 10 and V is 15. So all I have to do is plug it in. So that is Q equals 1 divided by 60 times 15 times 100. So I will simplify by 10. I will simplify by 3. And I get 5. 50 divided by 2 must be 25. Anything else? But again, if you had gotten to 8.4 in my last class, you would have had no difficulty with this. So it will look unknown as long as you don't find the time to sit down and work on this. It will always look unknown. Yes, is there anything else? Is there anything else? So let me get my syllabus so I can tell you where we are. So I'm trying to accomplish this today and hopefully start chapter 10. I don't have a handout for 9.2 to 9.4 because it's not going to be a problem. This is a long chapter and it requires a lot of effort, a lot of time, a lot of attention. So that's why I created that handout that I gave you today. But I don't have a handout for 9.2 through 9.4 because it's just very short. So I didn't create a handout for that. So that's where we are. This is a tentative date, so don't, carve it in stone. It's not going to happen. I need more time on this chapter than just 2 weeks, I don't think. We'll see. Maybe we can. So that's a tentative date for test 2. Any questions for me? Any questions? Okay, so we are going back to chapter 9. We did finish 9.1, if you remember. Let me show you. 9.1 was right here. Here it is, 9.1. But now we have to cover the rest of the 3 sections in chapter 9. So 9.2 through 9.4. Section 9.2 deals with absolute value equations. And I'm going to start with a very simple example. Let's say the absolute value of x equals 2. This is an absolute value equation because it has an absolute value in it. It's an absolute value of x. This, x equals 2, is a linear equation. But this is an absolute value equation. How do I solve this absolute value equation? It's totally different than how I solve a linear equation. Here is my thought, and I will put it in writing for you. I'm asking myself, first, let me just remind you, for example, the absolute value of 3, how much is that? Because this is the distance between 3 and what? Exactly. So please remember the definition of the absolute value. This is not the formal definition. That's something a little bit more sophisticated. But the absolute value of 3 is 3 because 3, this one, inside the absolute value bars, is found 3 units away from 0. What about the absolute value of -7? What would you say? Why? Because -7 is found 7 units away from 0. Excellent. Is that clear? So by definition, the absolute value of x is the distance between x and 0, whatever x is. Okay. So now coming back to my equation. Here's how I think about it. This is what goes through my mind. If you ask me, solve this, this is how I think. I'm asked to find these numbers whose distance from 0 is, because that's the absolute value, whose distance from 0 is 2. Okay, whatever I have here, it can be a sophisticated expression, not just plain x. So that's why I covered, just to make a point. Whatever I have in here in absolute value has to be 2. So I'm asked to find these numbers whose distance from 0 is 2. How many numbers have the distance from 0 to? 2 numbers. And they are? Why 0? Is 0 2 units away from 0? No. So the numbers are 2 and negative 2. And that's the answer. So the answer to this is x equals 2 or x equals negative 2. Now let's open up a little log. Let's say log of possible solutions to absolute value equations. 1. We solved one. We just solved our first absolute value equation. How many solutions did we get? 2 possible solutions. That's one option. There will be a second option, there will be a third option, and there will be a fourth option. We'll come back to those in a second or two. Okay. Here's my next example. The absolute value of x plus 3 equals 0. I'm asking myself what type of equation is it and how do I answer it, that question. I say that this is a absolute value equation. So I'm covering this in my mind and I'm asking myself, I have to find these numbers whose distance from 0 is 0 units. What can I have in here? Exactly 0 and only 0. So x plus 3 must be 0 for this to work. Therefore, x equals negative 3. How many solutions did this absolute value equation have? 1. So then I'm going to add my second option, 1 solution. Okay, let's look at a third possibility. Let's say 2 times the absolute value of x plus 4 equals negative 10. In this particular case, I have some cleaning up to do. Here I did not. This was a very simple, clear absolute value equation. This was a clear, no work needed, completely cleaned up absolute value equation. This one needs cleaning up. What do I do? I cannot start with multiplication. By the order of operations, I have to do what first? Exactly, subtract 4. You could, if you wanted to divide everything by 2. If you had said that, yes, I would have absolutely agreed with that. So then I have 2, the absolute value of x equals? Excellent. I still have cleaning up to do. This is not sufficient. What do I have to do next? Very good point. Let's write a big note. Note. The absolute value symbol is not a grouping symbol. The absolute value symbol, these two bars, in other words, they are not a grouping symbol, therefore they cannot be treated as a grouping symbol. What does that mean? You cannot distribute anything inside, you cannot take anything outside from the absolute value. You cannot touch it. This is untouchable. You cannot put anything in, you cannot take anything out. So please remember this. We're not talking about parentheses, we're not talking about brackets, and we are not talking about braces. This is a totally different concept. Whatever we know from these is not applicable here. So then something else must be done in order to clean it up. What is the symbol between 2 and the absolute value? There is no symbol. If there is no symbol, what is it? If I say 5x, what operation do I mean? Exactly. So if I say 2, the absolute value of x, what operation do I have here between 2 and the absolute value? What? It's multiplication, right? And I want to get rid of 2. How do I get rid of 2? Of course, I have to divide both sides by 2. Sure. So the absolute value of x equals. Good. Good. Now this is completely cleaned up. It's a clean absolute value equation. I do the same thing. This is what goes through my head. I imagine that I think in these terms. Okay. I have to find numbers whose distance from 0 is -7 units. Like I'm telling you, the distance between me and Nicole is -7 feet. So what do we conclude? What type of number is this? Can I say that the distance between me and Nicole is -7 feet? We're talking about the distance, right? So remember what we said. Let's go back for a second. We said I need to find numbers whose distance from 0 is 2. Now I'm asking you, I need to find numbers whose distance from 0 is -7 units. What type of number is this? What type of number is the absolute value of anything? Of course. What type of number is -7? Can you come up with a number that is positive but equals -7? So 7 equals -7. Really? 7 in absolute value equals -7? So what do we conclude? Absolutely. A positive number cannot equal a negative number. The distance, that's why I gave you the example, the distance between me and Nicole cannot be -7 feet. There's no such thing, right? And this is a distance. So the distance equals -7. Obviously, it says no solutions. So that's our third option here. No solutions. Okay? Is that clear? So the distance cannot be negative. If I have this situation, that's a totally different story. How do I clean this up? What do I have to do to this to consider it a plain, simple, absolute value equation? Excellent. So if I divide, that's a different story now. I divide the left-hand side. Careful, I did not touch the absolute value. I divided by -1 that is outside and it multiplies the absolute value. And I divided this by -1 that is totally different, right? Now, can anyone give us the two options for this equation? Exactly. You can always go back and plug it in. If you want to check, the absolute value of 7 is 7. Is the absolute value of -7 7? That's it. Good. So now let's look at another example and then choose some problems from the book. Here's one example for you. Let's say 2x minus 3 divided by 5 in absolute value equals 2. I'd like you to solve this in 1 minute. Can anyone get us started? And please raise your hand if you need help and I'll come over and help you. Can anyone get us started? what would you write as the first step? I can never do that. Careful. I cannot do anything inside. I cannot touch the inside. I cannot touch anything. Put in anything, take out anything. So I don't know how to solve this, but I know it can be changed into two different things. Okay, one more time. I'm trying to find these numbers whose distance from 0 is 2 units. What can I have in here? What are the possibilities? Can I have 7 in here? No, because the absolute value of 7 is not 2. What can I have in here? That's it. So I have 2x minus 3 over 5 equals negative 2, or 2x minus 3 over 5 equals positive 2. This I know how to solve. This, I'm just making a point. This I don't. But I can change it into two different things. If I solve these two, which I know how, I'm solving this. One minute. So in these two equations, I can multiply by 5, both sides. But in this one, I cannot. Please keep that in mind. So the first one is 2x minus 3 over 5 equals negative 2. What do I do here? Good. So then I have 2x minus 3 equals negative 10, and then? So 2x equals negative 7. And finally, x equals negative 7 halves. And the other one is 2x minus 3 over 5 equals 2. And I have the same thing. And I have 2x equals 13 and x equals 13 halves. So now, here's what I wanted to say. For this expression in absolute value to be 2, x must be one of these two numbers, nothing else. So for the absolute value of this to be 2, x must be either negative 7 halves or 13 halves. If you choose any other number and you plug it in, you will not get 2. Okay, so let's look at another example now. Let's try this. Now you should say, well, this is different from the previous examples. And I would have to agree. Why is this different from all the other ones? Why? It has both sides, or it has two different absolute values. Very good. So if an equation has 3 absolute values, we cannot use the method that I'm showing you now. You will not see 3 absolute values in this class, however. You will only see maximum 2. How many options do you think are there? So when I go back to this situation, I realize that this equation basically converts into two different equations. Okay. Now, coming back here, how many different situations do you think we have here? Very good point. Very good. Let's write those. Excellent. Thank you. One option will be that 2x minus 1 equals x plus 4. The second option, that 2x minus 1 equals the opposite of x plus 4, right? That's what we wrote. So we had the positive 2 and the opposite of 2. And what will be the third, or what will be the fourth? As if I'm looking from here. Excellent. And the other option, x plus 4 equals the opposite, very good, of 2x minus 1. Excellent. Stay with me. So let's look at this and analyze them. Would you agree that actually this is the same with this? If I say x plus 4 equals 2x minus 1, or I say x plus 4 equals 2x minus 1, are they the same? So there is no point in writing the third one. Okay. Now let's look at number 2 and number 4. What if I decide to multiply both sides of this equation? Let's say I multiply both sides by -1. The left-hand side now becomes this, and the right-hand side becomes this. But aren't these two the same now? This here and this here? So bottom line, those 4 different options really reduce to 2 options like before. The positive quantity and the negative quantity. The positive 2 and the negative 2. Okay, so we know now that even if we have 2 absolute values in an equation, they reduce to 2 different equations, not more. Okay, so let's solve the first one. I'm solving the first one right here. So I have 2x minus 1 equals x plus 4. I subtract x from both sides, and I add 1 to both sides. Take a moment and solve it on your own. You don't have to copy it from me. And then we'll solve the second one, which is 2x minus 1 equals negative x minus 4. Take a moment and solve it. I have 3x equals negative 3, x equals negative 1. See if you get the same thing. Any questions? Do we get the same thing? I'm getting my YouTube ready, because otherwise it will take a while. Okay. So did we get 5 and negative 1? So what does this mean? It means that the left-hand side in absolute value will equal the right-hand side in absolute value only when x is 5 or negative 1. These two sides will not be the same for any other number, but they will be for 5 and negative 1. They will be the same. Okay. Okay, one more. Let's look at 2x minus 1 in absolute value equals 1 minus 2x. Can anyone give us those 2 options that we are talking about? So even with solving equations with 2 absolute values, we still have only 2 options. Can anyone dictate those 2 possible options? I'm ready. Yes. That's the first option. Excellent. Parentheses, 1 minus 2x. Very good. Excellent. So let's solve the first one. I am adding 2x and I'm adding 1. So I have 4x equals 2 or x equals 1/2. I divide both sides by 4. I wanted to go back to 1 second here. When we write no solutions for an equation, that equation is called a contradiction. It has no solutions. It's a contradiction. The left-hand side can never be equal to the right-hand side. Contradiction. Okay. Good. So now I distribute negative 1. And I try to solve this equation. And I will add 1 to both sides. I should subtract first. I start with the x. I subtract 2x from both sides. I add 1 to both sides. What do I get?
0.
equals? Excellent. How do we call this? And how many solutions does it have? Yes, excellent. Infinitely many. And this is an identity. This and this, they're identities. So an identity has infinitely many solutions. I swallowed a T in here. I'm sorry. I'm going to write this one more time. Identity. Sorry about that. I looked at it and I said, that doesn't write. Right. So I omitted a T between N and I. Okay, so here it is, identity. Good. Since 1/2 is already included in here, I'm not going to write it again. Infinitely many solutions means everything, including 1/2. So the solution has, the equation has infinitely many solutions. And I can finally go back to my log, and I can finally add the fourth possibility. And here's the fourth possibility, infinitely many solutions. Again, this is an identity. This is a contradiction. And these are called conditional because they are false for everything else except what I found to work. So these are called conditional. Any questions for me? Okay, we're ready to choose a problem from your book. If you have your book, indicate which one. They are on page 563. Now you can choose anything you want from 1 through 68. In case you're wondering when is this used, it's used in tolerance and also the inequalities with absolute value that we are going to look at in a minute. So, any preference? You prefer one with one absolute value or with two? I can't spend too much time. You choose one. Okay. Let's say 54. Unfortunately, because we only meet, I'm going to use X instead of N because it looks like M and I don't want to confuse you. Unfortunately, with one class a week. That's why I posted the lectures from last semester with 2 classes per week, in which you have more examples than just what we do in one class. Okay, so can anyone give us the 2 options? And 4x plus 5 equals, yes, you can distribute it in one step, or you can write it so you don't forget, parentheses, and then you distribute. I need your answers. And then we move on. So always remember, there are 4 possibilities when we solve absolute value equations with maximum 2 absolute values. Okay? And of these types of linear, of course. What do you think about 5 being 3? Well, obviously it's a contradiction. No solutions. So for the other one, I have 4x plus 5 equals negative 4x minus 3. I will bring 4x and get 8x. I will bring 5 and get negative 8, so x equals negative 1. And how many solutions does this equation have? 1. Just 1 solution. This one is no solutions. Any questions? Any questions? Okay, 9.3. Absolute value inequalities. absolute value inequalities. Okay. Again, I'm going to start with two very simple situations, and then we'll branch off from there like we just did. Here it is, the first example. And here will be the second example. Maybe before we proceed, since I promised to put it in writing, maybe I should put it in writing for the absolute value equations. So let's do that. So the absolute value of x equals 2 means find x values, value or values, such that the distance between what and what?
X and 0.
Excellent. Is exactly what? 2 units. So this is a translation in plain English. You don't have to memorize anything. If you understand what we're writing here, you should never have to memorize this. Okay. Now, can anyone tell me what I should write for this one? When I say the absolute value of x less than or equal to 2, what does this mean? Find x values such that excellent. You can say this little thing means all this to you. Yes. Yes. But now we have to think. So the distance, so I'm looking for numbers whose distance from 0 is 2 units or less. Which numbers have the distance from 0 exactly 2? Where will I find these numbers whose distance from 0 is 2 or less? Thank you. So the absolute value of x less than or equal to 2 converts, I cannot, don't do that, I'm just trying to make a point, converts into exactly what Heather said. We cannot solve this. This is the way we solve it. We think. Okay? So numbers whose distance from 0 is 2 or less must be found between -2 and 2. Is that clear? So if I look at the real line or the numbered line, here it is. We have -infinity, infinity, and 0 in the middle. Okay? So -2 is here. No measurements, no units. I don't care. I just need to explain this. So these 2 points represent the solution to the equation. This territory represents solutions to this inequality. So in interval notation, how do I write this? Yes, -2, 2. Excellent. Now stay with me because I would like to solve the other one now. Can anyone tell us in plain English what does this mean? And it cannot have anything to do with this one. Nothing in common, right? So this one says,
Less than.
what does this one say?
Less than.
Careful, I changed my position. I know I look silly, but if this helps you, I'll do it. I changed my position. I'm not saying this. What am I doing now?
And it's going to be or. You're going to have numbers on one side, numbers on the other with nothing in the middle.
So the solution will be here and here. That's why we studied 9.1 first, right? Because now we know what OR means. So how do I solve then this inequality? I don't know, but how do I change it into? And of course, they have to be two totally separate situations. One which is here, and one which is here. How do I write that? I'm not changing symbols or anything like that. This is where the solution is. So what is the first one? Very good. X greater than or equal to 2. It's this territory. Very good. Okay. And how do I express the other one? If it's greater than or equal to, you are including this territory, and I cannot do that. You cannot touch this. This is already taken. So that's why I showed this, not this.
So it's to
X,
Less than or equal to negative.
exactly. So one more time, these two cannot include the middle part. The middle part is already taken by something else. So it has to be this or this, right? So if it's this, the distance has to be less than 2. If it's this, the distance must be greater than or equal to 2. Because a number here definitely has a distance from 0 much bigger than 2. And the number here, definitely it has a distance from 0 bigger than 2. So I'm looking for numbers to the right of 2 or numbers to the left-hand side of negative 2. In this case, how do I write the solution? And Heather already told us. So how do we write the solution for this? X in the interval. We did this, and this was on the test. So we should be acquainted with this. It's right here. You just have to dictate it to me. It's in blue. You just have to dictate it, and I'm going to write it.
So, is it parenthesis negative infinity, -2 bracket, and then the other one is bracket 2 negative.
Very good.
Bracket 2.
Very
negative
good.
infinity.
That's it.
I mean,
Very good. That's the answer. So this is the difference between the two. I don't want you to memorize, because if you memorize, you will mess it up on the next test and the final exam. So all you have to do, look at the inequality and think. Okay, so now we're ready to practice. This is on page 569. And you can choose, I'll choose. Let's start with 52. And this is 3/4 x minus 1 greater than or equal to 2. So I know there are two possibilities here. One possibility in which the absolute value is less than or equal to a number, in which case I'm looking for this. And the other possibility is when the absolute value is greater than or equal to a number, and I'm looking for this. Which case is it? I'm looking for in between or the exactly. So it's the more difficult one. It's not the easy one that I can write in a chain and solve everything together. I have to write two different things. Very good. So please tell me what to write. How to convert? Nobody knows how to solve this. But we know how to convert it. And then we will be able to solve it.
3/4 x
Yes?
minus 1. Yeah. Greater. Yeah. Sorry, I went out the door. Less than or greater than
positive 2,
Good.
and then the opposite would be the negative 2 at the bottom. Oh, yeah, less than or equal to negative 2.
Excellent. Let's solve these two. 1 minute. Very good. We cannot solve them together because one of them is going to be to the right, along far away, and the other one will be to the left, far away. They have nothing in common, and they cannot be put together. And we know now that the solution will have what? The what? What am I showing? The union. Perfect. Very good. So 3/4 x minus 1 greater equal to 2. What do I do first here? Yes, you could, but I would rather add 1 first. 3/4 x greater equal to 3. And then I want to eliminate 3/4. How do I eliminate 3/4? Meanwhile, it's multiplied by x. So what do I do to both sides to eliminate 3/4? Exactly. So this is obviously 1. That's what I wanted. And here I simplify. Of course, I'm not going to multiply first. So the answer is 4. Now the other one is 3/4 x less than or equal to negative 1. And again, I want the same thing. I'm adding 1 to both sides. I want the same thing. I want to clear the 3/4. How do I clear the 3/4 again? So then x less than or equal to negative 4/3. And now someone should give me the solution.
Negative infinity, negative 4/3.
Very good. Excellent.
And bracket 4 to infinity.
Excellent. Good. Let's look at some other examples. Let's say 46. The absolute value of x less than 0. Some of these inequalities could be or can be tricky, so you have to be very careful. Look at this carefully and say or ask yourselves, what type of number is this? Always. What type of number is this? Well, 0. Can you give me an example that is a positive number less than 0? No. So what do we conclude? No solutions. Okay, let's look at one more. 48. 5 plus the absolute value of x greater than or equal to 4. This is a absolute value inequality, but it's not cleaned up. What do I do to clean it up? Yes, I have to subtract 5, move 5 to the other side. Very good. So then I get the absolute value of x is greater than or equal to? Good. Again, I have to think for a moment. And I know that the left-hand side is what type of number? And I know that the right-hand side is what type of number? So now I'm asking myself, okay, is a positive number greater than or equal to a negative number? We certainly hope so. So once again, is a positive number greater than or equal to a negative number? Always. So what do you think about this inequality? Let's give it a shot. 0. The absolute value of 0 is 0. Is 0 greater than or equal to negative 1? You prefer to have 0 or be in debt of $1? Which one you prefer? 0 is bigger than negative 1. What about 10? The absolute value of 10 is 10. Is 10 greater than or equal to negative 1? 15. Let's say negative 15. negative 15 absolute value is 15. Is 15 greater than or equal to negative 1? So what am I getting at? Yes, since a positive number is always greater than or equal to a negative number, infinitely many solutions. Very good. Okay, let's also look at this, 57. The absolute value of 1 plus 3x plus 4 less than 5. Okay, so what do you think we should do now? I claim that it's not cleaned up. Yes, 1 plus 3x in absolute value less than 1. It's completely cleaned up, and now I don't know what to do before I think. And I know there are only two options. I'm happy they're not 15. Yes, so it's this, not this. Okay, how do I convert it? Again, I'm trying to make a point. You don't have to do that in your notes, of course. We don't know how to solve this. But I know if I know how to change it into something I can solve, then it's done. What do I change it into?
1 plus 3x plus 10.
And then the other one would be 1 plus 3x negative 1, right?
So what is the relationship between one? Because you said 1 plus 3x negative 1.
Oh,
So what do you think?
Less than negative 1.
Less than negative 1 will be far away, and the distance will be more than 1. So we have, do not make the mistake, I shouldn't say it's a mistake, but do not separate. In this particular case, you don't have to separate them. It's easier to keep them together. So in this situation, I have no choice. I absolutely have no choice. I have to have two separate ones because this is far to the right and this is far to the left. So I have no choice here. But here, I'm asked to find numbers whose distance from 0 is less than 1. So they have to be between, they are found between negative 1 and 1. This will not be enough. This will not be enough. Actually, it will be a mistake, and as well as this. So I have to conclude that these numbers have to be found between negative 1 and 1 because then their distance from 0 will be less than 1. So what do I do next? Yes, negative 2 less than 3x less than 0. And what do I do finally? Yes, so negative 2/3 x and 0. And this is the interval notation. You don't have to intersect. If you separate them and then you forget to intersect, you're not going to get the solution correctly. So this is x in the interval negative 2/3 comma 0. And if I don't write x is in the interval, I may conclude that this is an ordered pair, x comma y. So this is clearly the indication that that is an interval for x. Any questions? Any questions? Again, between now and next Thursday, if you don't finish all your MyLabs Plus homework from this chapter, because I'm going to continue to the last section right now, you're going to come back and you're going to be a week behind. So the homework that I recommended, they have that sheet, should be done first after you redo all problems we do in class. And those do problems that are, they have the answer in the back. And then you should say, well, I studied for a couple of hours. Well, now I should be ready to do the homework in MyLabs Plus. Yes, homework in MyLabs Plus, I have to be honest, it's a little bit tedious.